Okay, let's learn how to use one of these things. This is a button. You press it and you can do stuff with it. One thing that is confusing about the button is it has 4 pins underneath when it only needs 2. Yeah, it needs 2 pins, and when you press the button it connects the 2 pins. It's a little bit confusing that 2 of the pins are connected and then the other 2 are connected, and when you press it, it joins both of them together. So what I like to do is, you can actually just snap these off. Yeah, the diagonal ones. So grab 2 diagonal. I apologize for how confusing this video is. Hang on, I got my pointing stick. There you go. One there, and one there. Yeah, so the diagonals of the square. So snap off 2 of the pins on the diagonals. That pin and that pin. If you're not sure, ask me and I'll help you out. Maybe, if I'm feeling nice. No, of course I'll help you out. And if it is a bit tricky to snap, you can use these. Just be careful you take your fingers out of the way. There you go. Beautiful. And then it's just a bit easy to deal with, because now we've got a thing that's just got 2 pins. Yes, 2 is less than 4. It is half of 4. And now I can put it in my breadboard. Wonderful. Get in there. It might need some persuading to get in there. Squish. There we go. Beautiful. Okay. Now, for this program to work, I'm going to hook it up as in here with 1 pin going to pin 7, lucky number 7. And the other pin, this one, going to ground. Okay. Why pin 7? Any of the pins will work. You can do pin 2, pin 11, pin 13, lucky pin 13, whatever you want, as long as you are consistent. Anyway, pin 7 goes to one of these. Notice that the pin is there, so I can connect it in any of these in that same row. Maybe I will connect it to this one, right? This one. There you go. That is in the same row. Okay. The other one goes to ground. GND. There you go. GND. And that goes to the other pin. Yes, the same like row there. Alright. When I press the button, these 2 things are now connected. It's as though one wire was connecting both of them. Alright. What does the code look like? Well, that's a bunch of gibberish. First of all, we need our setup code. To make this a bit easier for you, you can start with examples, basics. Bare minimum. Bare minimum is a good example to start from. There we go. Alright, put your setup code in here to run once. Well, this pin 7 here, is an input. Yeah, it's information going into the Arduino that I am providing to the Arduino. And pin, this LED, is an output. So I need to set pin 13, which is this LED, to be an output so I can turn it on and off. To check that that worked, let's do digital write pin 13 high. That will turn this LED on. Check that it works. Compiling sketch, compiling sketch, compiling. Oh, uploading. That's better. There we go. Beautiful. It turned it on. Wonderful. It works. Okay. I don't need this comment. I'm going to get rid of it. You can leave it if you want to. It's your choice. It's a free country. So, I want to detect if this button is pressed. This is connected to pin 7. Pin 7 is an input. I was saying that before. So let's declare it as an input. To declare something as an input in Arduino, you can use input. Because we are using this as a button, we use an input pull-up. What that means is that when the button is not on, this is going to get pulled up to 5 volts. So we'll get a high voltage signal. And when we press the button, well, now it's connected to ground. So it's going to be 0 volts. You just need to remember, if you're using a button, input pull-up on that pin that you're using. We're using pin 7. So maybe I'll say if, actually better, let's wait until we press the button and then turn the light on. So how do we wait until this button is pressed? We can use a while loop. We want to do this while a read of this pin, digital read is the opposite of digital write, of pin 13, As long as this thing is high, we will wait and do nothing. Yeah, because it is normally high. Normally, when nothing is connected, pin 7 is got a pull-up, input pull-up, which means that normally it will be high. When we press the button, it will go low. It's a bit backwards to how you would normally think of it. When you press the button, it goes low, let go, and it's high. If it's high, we just want to wait and do nothing. Oops. So this is a loop that waits. As long as it's high, it just waits and waits and waits and does nothing, does nothing, does nothing. And then we can do something after that. After that, maybe let's turn the LED on and then wait for a second and then turn it off. Digital, right, pin 13, low, and wait for another second. That way we'll know that it works because it'll flash the light on for a second and then flash it off for a second when we press the button. So set pin 13 to be an LED output, pin 17 to be a button, as in the loop, as, oh no, expected semicolon. Oh, well, I guess I forgot a semicolon. I accidentally did a colon, which is one of those, instead of a semicolon, which is one of those. Who knew you were going to get an English lesson? Ha ha ha. Okay. Well, this is strange. It's blinking already. Scratch, scratch, scratch. You know why? Because we don't digital read on pin 13. Pin 13 is our output. That's the LED we're going to turn on and off. The information that we're reading, the input that we're getting, is this button is the input that we're getting. What pin is the button on? No, really, tell me, what pin is it? You go to it. It's pin 7! Pin 7! There we go. So digital read will normally correspond with your pull-up pin. Yeah. You can put comments here. Pin 7 is a button. Pin 13 is an LED. That makes it easier for people to understand your code later. People like you. So this will keep doing nothing for as long as it's high. As long as this pin is high, it'll just loop over and over again, just stuck in here, doing little circles, just waiting, waiting, doing nothing, over and over again. And then when I press it, this pin will go low, so it won't be high anymore, so it'll keep going. And it'll turn the LED on, wait a second, turn it off, wait a second. And then it'll get stuck in its loop again. Let's try it. I press the button, it turns on, waits a second, turns off. And now it's in this loop. I press it, and then it goes on, waits a second, turns off, waits a second, and then it's in the loop again. And that, my friends, is how you control something with a button. All the button does, by the way, is connect these two wires. So I can also just control it directly. Boop, boop,